Hello, my name is Ratmir Karabut with More Smoked Lead Chicken, and I'm presenting a Windows Remote App-based challenge called Minesweeper Extreme. The app is a Minesweeper clone forked from Robert Mikhailyan's project written to demonstrate the usage of the WinRT bindings recently introduced in Rust. For the purposes of the event, it was served to you through Remote Desktop Protocol. Of course, no one considers reversing Rust very fun at the moment, me included, but still I decided to not share the updated source code along with the challenge binaries, leaving that as a hint for later. My thinking was it would be reasonable to leave a bit of reversing in, given that the changes weren't that extensive and as such would not be too difficult to track down. As listed in the description handout, there is a number of extreme upgrades done to the original game. The most relevant, of course, is that when you win the game you get the flag printed out, and the close second is the field is now 90% mines. You can also enable in-game debugging now, which is not very useful to be fair, giving you some extra log output on the info level, which is how it was being run on the server, and also showing some basic information in the window title. The debugging can be switched on through entering the ancient Minesweeper cheat code XYZZY Shift Enter Enter, which in the original Windows Minesweeper would give you a hint when you hover the cursor over a mine. It doesn't happen in this version. Well, in a sense it does, but more on that later. The added difficulty levels make it possible to play the game with the field up to 22 by 22 tiles in size, keeping the mine count at 90% of course. The reward stays the same, you solve the game, you get a flag, so at a glance it doesn't seem to be that useful. Another change though is a misguided attempt to optimize the animation that plays when you click on a mine. The tiles set to be animated are now determined ahead of time when the player hovers over a tile, which of course only makes the calculation happen much more often, and crucially not happen at all if the tile is actually clear. And here you can see the actual exploitable part. In a critical section of the code getting called for every mine to prepare the losing animation, when the in-game debugging is turned on, a portion of the game state gets formatted into a string and put into the state info variable. The contents of this variable are supposed to be shown in the window title, but it never happens because it gets overwritten with the coordinates and mine count before the title gets updated anyway. However, this introduces a visible delay between hovering over a tile and the selection frame appearing, which gets worse with increasing the mine total, that is, the difficulty level. Also, when the login level is set to debug, all that state gets dumped to console along with the actual coordinates of the mine, which should make the problem much more obvious when running the challenge locally with that setting. Unfortunately, I had to make this part a lot more obnoxious than it used to be at first iterations, pretty much dumping the whole state into a string, as while the initial, subtler delay was quite enough to measure response time reliably over a local network, I figured it would be very frustrating to exploit with an overseas server, definitely possible but prohibitively time-consuming for a CTF. So the reference solution built with the AutoGUI Python library works like this. You connect to the challenge, run the script and leave the machine for a while as it enters the cheat code, switches to the highest difficulty and starts moving the cursor in and out of every tile in turn. When the latency of the selection frame appearing consistently falls below a minimum set according to network circumstances, the script clicks on the tile. It also remembers the tiles it should definitely skip on following passes and takes into account the revealed numbers. The script finishes in under 10 minutes over a local network, but with increased delay and packet dropping it could take the best part of an hour for a remote server. Unfortunately, I have not been able to think of an acceptable remedy for that. An obvious step would be to increase the timestamp granularity of the console login, for example, but that appeared to make the challenge much easier. I fully expected some of the teams to actually invent unintended bypasses and break into the server through escalating the provided RDP access, as limiting it to the Minesweeper app turned out to be quite a challenge in itself. As an example, one of the bypasses found early was just opening a hyperlink in the CMD menu and using the browser to show the flag. In this case, preventing Internet Explorer from running worked, and I gave it my best to secure the challenge otherwise with what meager Windows Server skills I have, but it would certainly be cool to see those attempts circumvented. I hope you had some fun with this challenge. I thought a somewhat realistic timing attack would make for an interesting detour, and I guess I wasn't the only one for this event, and making it more visual has been interesting to me as well. I wish I didn't have to make you solve this over the internet of course, and I wish we don't have to run into such problems next time. Thank you all for playing, good luck, and take care.